Good morning, David.
Morning.
Excellent. David, it's a pleasure to have you take part in our CTO News Thursday vlog series. And, we're really keen to learn more about you, to learn more about Blue Dot and the amazing solutions and offering that you're providing to the TaxTech sector. So let's dive straight in. Let's get straight into it. So in the first instance, please can you introduce yourself to our audience?
Sure. David Guedalia. I've been in the high-tech world for about 35 years, I'd say. Did degrees in computer science, geography, and neurocomputation. And my favorite thesis is an online agglomerative method of clustering, which has to deal with how do you deal with data as it shifts. So dynamic data is a big part of our life, mainly because we're human and things are always changing. So how do we live in a dynamic world? And then the data reflects that. Right? I guess if we were measuring static things that never change, or geological time, we're measuring rocks, it's going to be less interesting. But in the world I'm in now, in the fintech world in particular, you see human behavior changes all the time. Sometimes you have a mega event like COVID, and sometimes you just have minor shifts. We notice behavior shifts around different types of milk and coffee. People use coconut milk, almond milk now. The world changes all the time. So that was my degrees, and then I was in a bunch of different startups, image processing to telephony to IoT, Internet of Things, Bluetooth beacons and stuff like that. And now I'm here at Blue Dot.
Fantastic. Thanks for sharing. Sounds like you've got a wealth of knowledge and experience, and it'd be great to learn how you've adapted that in your current role at Blue Dot. So what is Blue Dot?
So Blue Dot started as a well-defined, it actually had a different name. It started at VATBox, and it had a very well-defined product. It was trying to help you, as in large enterprises, recover VAT, value-added tax. So what happens in most large companies, most big word, and when I say large, I mean very, very large enterprises, the top 100 companies of the world. So you have 1 million employees, they go off, they buy cups of coffee, and they want to, it was a business expense, it was an expense of some type. How do they get reimbursed for that? So most large companies have some system where you file for a request to be reimbursed, or there's a method for reporting it. The word report is a problematic word, but employees report their event. And then they have to, with the event that they report, they need to provide an evidence, justification, why that event is legitimate. So a cup of coffee is easy, but let's say taking a train to a meeting, or you're taking a flight, went to a hotel, all these things. And the simple product we started with was just helping large companies at scale recover VAT. And the reason that was a problem is because it was a manual process, and you have millions and millions of these receipts coming through. And how do you analyze them? And what was being done in the industry until we came along was some level of sampling. You assume the employee reports are correct, you sample to detect certain issues, and you go. But to manually look at every single invoice is a challenge. And we avoided that through automation. So that was our first product. And what we discovered along the way was that really there's been an entire shift in the way people do their purchasing. In the old days, in these large companies, before you bought anything, I don't know if you had this experience. I don't know what, I was in a large company once, and you need to open up a purchase order. I want to buy a pen. All I want is a pen. No problem. Let's go to the finance department. We'll open up a purchase order for a pen. Oh, wait, you're only allowed to buy it from the following vendors that we have in our system. Staples, Office Depot, whatever. Great. Then you fill out and then it's pre-authorized. So we lived in a world where all the data was pre-authorized, it was pre-validated, and then the quality of the data was very high. It made the user experience lousy, but the data you had was high. What happened over the internet world is now I want to go on a business trip. I need to go to a meeting in Munich. I open up booking.com and book myself a flight. The financial departments don't have control over that. The data I'm going to enter may be very noisy. Often it is. And it's partial. And and the entire consumer purchasing experience has transitioned into the enterprise. And this has created a situation where the data is very noisy. And so when we solved the VAT problem automatically, we were forced to solve the data problem. And that became the pivot point. So now Blue Dot shifted from VATBox, where we don't think about a particular application around VAT. We think about all the little dots that compose the story of your report, your employee transaction. And we then compose that picture. And with that, we now can create multiple products that service the financial industry. Long answer. I apologize for the length, but it covered history and present.
Absolutely, and that's fine. That's absolutely fine. It's always good to give context, to the growth and what you're engaged in at Blue Dot. Fantastic. So, why is technology crucial to your organization?
That's a fun question. So, I think the first my knee-jerk reaction to that question is, how could it not be, right? Technology is not a thing that's external to us anymore. I think in the old days, like my grandfather was an accountant, and whenever I tried to explain to him what I did, it didn't work. And I think what happened was that he used technologies as tools to achieve his goals. So he had his goals, he had his tools, and they were separate entities. I think our life is one where technology has become a part of our life. It is not an external tool. It is our life. So that's why I'm smiling. I think technology has to be part of the solution because it's part of the problem. The way the problem's created is through technology. We have access to many vendors. We can buy on Amazon. We can buy in Staples. We get the ability to quickly purchase things technologically enabled. Then the ability to analyze that must be technologically enabled as well.
Yeah, 100% agreed. And I think that quite leads me on to my next question, which is, how do you view AI and machine learning at Blue Dot, and what benefits is it providing not only to your organization but to your customers?
Right. So, okay, this is going to be the longer answer, which is we differentiate between 4 or 5 different things. So there's automation. Automation is the process where you have typically a human mechanical process, and you automate it. That means a robot performs exactly what the human did. That's one type of process. There's digitization, where the process is digitized so that instead of having a physical person or a physical robot perform the automation, it's done digitally. Then there's what we call, let's say, modeling. In modeling and statistical analysis, what you've done is you've gone beyond just repeating the task that the human did. You've created an abstraction. You understand some aspect of what the task is, and you provide a model that can not only solve that particular problem, but can expand. It can go and solve problems that are similar to it as well. Then there's AI. And I guess my definition for AI, beyond being just a series of models, it's a series of models of statistics that expand beyond just being able to provide a solution to this problem. They create tools that can help us solve many problems as well. So at Blue Dot, what we've done is we've done all of those to certain degrees. Right? We started off here and we're there, and we still have parts of our process with issues that's just digitization. We have some simple models in place as well, but we also have very complex AI, I think cutting edge technology that enables us to reconstruct entire transactions. And by doing that, we're going beyond just understanding what previously, let's say, an accountant or in the finance department, they would look at the report of the employee. We're looking at many reports. We're looking at many vendors. We're looking at behavior in continents and in countries and cities. And we're able to then abstract those ideas and then look at how that can help us solve many different types of problems.
Understood. It absolutely, it really does come down to sort of the granular nature of really, especially when you're looking at sort of enterprise organizations who are, dotted across, the 5 continents of the world. And the idea is to try and understand, how an individual, whether it be region, sector, even, in the UK, we class it as postcode, is performing with regards to their tax compliance, etc. So, yeah, understood.
Let me give you an example, because I realized I didn't really answer the second half of your question well enough about how our customers are leveraging this. So here's an example that we come across, which is searching for a specific type of a transaction. So, for example, alcoholic transactions, you buy a beer, it has different ramifications in terms of tax. And in England, it's 22% VAT, depending on also. And being able to identify that there was you bought an alcoholic drink, you would think it's simple. I'm just going to search for the word beer, right? So I think the automation process would be, well, I know the word beer is alcoholic. I will just automate that and look for BEER. Okay, and we can do that. But the chances of that succeeding are quite low because there are many words that are similar to beer. So then if I go to London and I happen to go to a certain cafe, I'll get Camden Pale Ale. Camden Pale Ale is a beer, but it doesn't have the word beer in it anywhere.
Yeah.
So the ability to expand beyond just that word, beer, and to see Camden Pale Ale as a beer, right? The things that go on to solve that type of a problem, we do at a semantic word level. Okay, what does the word ale mean? It can mean multiple things. So
absolutely, yeah.
That in itself is part of the solution. Okay, but where did you buy it? Oh, you bought it in a place that happens to be called the bar at the corner. Oh, okay, the word bar at the corner gives a hint too. But wait, we can look at who else bought other things at the bar at the corner. Now we have a history of purchases from that place. And then we can see, oh, people who bought Pale Camden Ale also happen to buy pretzels a lot. Oh, and do you know that people that buy pretzels in northern London also buy beer, BEER? Okay, we've solved it. So that level of abstraction and interconnectivity is enabled when you start to construct multiple models that are interacting with each other in this method.
Yeah, absolutely understood, and that's a really good analogy and a great way to sort of explain that the challenge that you're solving. Absolutely, excellent. So, what is unique about this approach for the financial sector, and how can it sort of whether it be beneficial for other industries?
I think again the key fallacy is a strong word, but the key innovative approach we're leveraging here is to avoid supervised learning. That's a technical term, but what happens in most of the industries today is you shoot the arrow and then you draw the target. You say, okay, I'm going to solve the following problem. I know the problem. I know the solution. I need to automate that. And then that got a little bit refined to, I'm going to solve the following problem. I can define the problem. I don't know exactly the solution, but if I define the problem well enough, the solution will get constructed by a model. So the typical process would be, I need to find lost keys. I have a lost and found department, and I need to find the lost keys. So I know in the past that the way to find a lost key is to look in people's bedrooms because that's where they lost the key. When they thought they put it in the kitchen, they put it in the bedroom. Or I know it's in the office underneath the chair because that's where people. So that would be the old school. The current school says, no, I'm much more competent. I have machine learning models. I have data scientists. I have annotators. I'm going to gather data. So I'm going to go down the street. I'm going to film people finding keys and then annotate that data. I'll say, in this scene, the person found the key. I'll then train a model on that video to detect what the best locations is to find the key. Sounds great until you realize that all your filming was done under the lamppost because that's where the light was. And in the dark areas, you have no film. So that's the current situation, I think, in the industry in general. And it gets hidden because people are very clever and they're able to describe problems in ways that they think they are describing a general problem. But in the result is they focused their observations to under the lamppost.
Absolutely. In essence, the map is not the territory, as they say.
Right. Okay. So then our innovative approach in Blue Dot is more unsupervised. We look at the data and we try not to be judgmental. We try not to say this is good data, this is bad data. We try not to say this is under the lamp. No, we just get as much data as we can. We let the data tell its own story. That's our theme. And by doing that, I think that's really can be adopted cross industry. This idea of trying really hard not to fall into the supervised trap.
Yeah, absolutely understood. And thanks for explaining. Really clear. Okay. So what are connects and transformers? If you can translate that for layman's like myself.
Okay, I think boy, I have a lot to say on that topic. And okay, connective networks, which are really the CNN is a little bit comes from the DNNs and the CNNs. They come from this world where there's an assumption, and it's often, again, it's under the lamppost assumption, but because it's a valid assumption, I think it's a valid assumption, people don't notice it. The assumption is that in visual problems, spatial distance is valuable. So I'm looking at something, the distance between 2 points is a valuable piece of information. Right? You could say that the world was organized randomly, and that when I see a scene, my brain somehow puts all the different pieces together. But it doesn't seem to work like that visually. And neurologically, if you look at the eye and you look at the retina and you look at the way the cones and the rods are organized, and then you look at the way the brain kind of deals with the first level processing, and then all the way to V1, you see spatial distance is very important for visual tasks. Okay, not a mind-blowing idea, but it's an obvious thing. But then they went ahead and they decided, well, we're going to build an artificial neural network. We're going to bring a connectionist machine. We're going to leverage that. And the first thing they do is they say, okay, so then I have a picture, and in the most popular way, I'm going to take a 3x3 part that's spatially, again, in the visual space, very close to each other. I'm going to assume there's something valuable in that information. And they run across 3x3s, and then they do, well, maybe I'll take 3x3s. So now I have a 9x9 block, but it's composed of lower level 3x3s, etc. And you build up this hierarchy, but the fundamental assumption is that visual data is spatially salient. That works very well. So it works very well because it seems to be true, and the human brain seems to use it. And it's a very good way to solve visual problems. The challenge is that it's not a very good way to solve semantic problems. So the fact that spatially distance is very valuable to identify light and dark or colors or edges, or that may not help you identify that the dog is eating your homework, right? The dog eating the homework requires a lot of semantics. It's a dog, and then it's eating something. Oh, and it's my homework. Maybe it was just papers, maybe it was with stuff. So that's a lot of semantics that have to get incorporated. So I think that the answer to your, CNN is going to be that, as a rule, it's some sort of visual-based learning, but it's been expanded to things beyond less successfully.
Yeah.
Obvious.
Brilliant. Excellent.
The second one you asked was, I forgot already.
Say again, sorry?
What was the second half of that question?
So I asked, what are convnets and transformers?
Right. So convolutional networks is what I was describing, where the visual spatial distances are convolved. They're taken with a little bit of a function, a mathematical function. But basically all it says is, if I have visual spatial elements, let me ask different questions about it. Is it homogeneous? Is it an edge? Is it not? That's the convolutional question. Something else is transformers. Transformers says, I've built a model. I now have, what happened is that as more and more data comes together to create these models, and data is important because it enables you, if you have a reasonable structure, to broaden your mind and to see different types of things. So if I grew up my whole life in a sunny state, and all of a sudden I have an autonomous vehicle and it's driving in Sweden, and it's raining and snowing, it's unlikely it's going to spot the deer crossing the street. So I need to have examples of both the rain and snow and the sunny, and I need to get the London fog, and I need to get all the different cases. Lots of data. That's great. Okay, but now I've built one of my convolutional networks with lots of data. It cost me $10, $20 million to do that. Now you come along and say, I would like to leverage that for my problem. I have a different problem. So comes transformers. Transformers say, someone builds a model, spends a lot of money on building that model, and another company can come around, another person can come around and leverage that model for their particular problem. It's an amazing thing that just like open source has taken over the world, and there's a lot of free code. Code has been transmuted in our generation to models and to data. And there's a lot of open source models out there. And I take them, I can use a transformer as I take an existing model and I transform it to my particular problem. I save a lot of engineering costs, a lot of computational costs, and then I can focus on just making minor adjustments so it'll help me solve my problem.
Wow, amazing. That is, yeah, mind blowing, as they say. That is yeah.
Right. The same way that open source revolutionized engineering and transformers and standardization of networks has revolutionized modeling.
Yeah, yeah, absolutely. Okay. So you've stated in a blog that you wrote in the past that scaling up meant paying attention to Blue Dot's keystone. And at the time, your keystone was systems and software architecture. Today, the keystone for your organization is data. For the keystone for any organization is data. So how do you ensure the right data is available for other precious resources at Blue Dot, i.e., time and people?
Yeah, that's a really hard problem to solve because we opened up, people change and their needs change all the time. So I guess the bad answer I'm going to have to give you is you have a team of people whose job it is to make sure that the data is available, and they're working very, very hard because they're always using different tools. We've gone through in the last 2-3 years, I think 3 or 4 different tools to access data. We have 5 or 6 different types of databases, relational and not relational databases. And the ways we look at the data is just use everything all the time.
Mm-hmm.
So that's the bad answer. I don't have like a really elegant solution that says, oh, if you just use, trick number 23, it works. No, I don't think so. It's a very intensive process. That the whole idea that moving over to machine learning is going to reduce your number of engineers you need or the number of people working is a fallacy. It just increases the amount of work. You're just doing different work. So that's the short answer. The longer answer is going to be that data is needs to be aggregated and absorbed, but it needs to be understood too. And the ability to create, so the different terms we use in the industry are called feature stores or semantic search within your data. So the ability to organize your data in ways that you can find it later is invaluable, of course.
Mm-hmm.
The way to do that, at least for us, has been to create our own tools on top of, like, not to expect that the industry is going to have a tool for your business. We were forced to create our own tool on top of that. So we have I don't know if you've seen, I don't know if we have a video clip out, the visualization tool we use to see multiple invoices, where we have a graph that demonstrates the relationship between the invoices, and it can be navigated, and you can zoom in. And there were just some obvious problems. You have a billion invoices in the background. You can't see a billion on your screen. So how do you visualize some projection of that? That's a problem. How do you zoom in? And we had to solve those problems because that was valuable to our data problem.
Yeah.
So I would definitely recommend assuming that the tools that are out there will not provide what you need, and do not assume that it's going to reduce your engineering costs to move over to a data centric. What it will do is it will enable you to scale up. It will enable you to be more flexible, being able to serve your customers better. All that's true, but there's a lot of work in getting the data right.
Brilliant. Excellent. Thanks for sharing. Okay. Why does data force us to move from memorization to learning?
Okay. Funny you should ask that question. Yeah, I think the short answer is going to be because you're limited in your resource. The more data you have, you can't memorize all of it. So having a limited resource, our brains are finite in their skull. That's it. We're not, at least until Elon Musk perfects the Neuralink thing, we're kind of fixed in our finite space. And we've developed a system where we have like short-term memory, which will be about, let's say, what did I see today? And then overnight, that will get pushed deeper into the brain. Well, that pushing it deeper into the brain process, I'm convinced, is a process where we're going to have to learn, because we can't just constantly push everything you see into the brain because there's a finite limit. So having constraints in our life, it's a Kabbalistic concept, the idea of tzimtzum, the idea that God created constraints to his infiniteness so that he could have room for the world. It's the same idea. It's like, if the world was infinite, we wouldn't need to learn anything. Then we wouldn't have to have any progress in life. We would just memorize everything and communicate through memorization. Having the finite limits on our brain, on our communication channels, on our etc., I think that's one of the wonderful secrets of life. It enables us to learn and to adapt, and it forces us to be creative.
100% agreed. I think you're talking in the realms of sort of the subconscious and the conscious, and in terms of how your mind operates. So, yeah, the conscious is obviously what we do on a day to day, but subconscious is really what affects our behavior, our learning, etc. So I completely understood. Excellent. All right. So my next question is, how do you learn something quickly, particularly when paying attention to the structure of information?
Okay, so I think that one is, it kind of ties to the previous question to a degree. But if you think about learning something
Mm-hmm.
and try and learn it by memorization.
Yeah.
So you focus on all the details.
Yeah.
And then you go through all the details.
Yeah.
The ability to memorize a lot of details is a challenge, right? If I gave you numbers to memorize, we get to about 7, and then it starts to get hard beyond 7. That seems to be the magic number.
Mm.
Right. So what do people do when they give a memorization task? I don't know if you've ever gone through these tests where they try and, okay, how many words can you memorize?
Yeah.
One of the tests is you build a story. They tell you, build a story. Oh, Jane put a dress on and it was white, and then the phone number was 7, and she called her friend. Why does that work? Because you're starting to create a higher level structure to all that data.
Yeah.
What happens when you create a higher level structure is you're creating a new language.
Mm-hmm.
I could try and describe, okay, I am now holding well, you can almost see it. It's
Yeah.
invisible because the background works. Maybe. I'm holding a cup, but I could say I'm holding a cylindrical thing, which happens to be a container, a vessel of liquid. And then you'd say to me, could you please pass that cylindrical thing that's a container, a vessel of liquid? That would be the long form way of communicating. Or you could say, pass the cup.
Yeah.
So we've created the word cup because it's a much more efficient way to communicate all those other words.
Yeah.
So the more structure we can have, and the more we're able to create the higher level concepts, the more efficiently we can communicate.
Absolutely.
It's pretty straightforward. I mean, it seems like such an obvious idea, but it's the fundamental of the difference between memorization and learning is the ability to compact all that data that we're memorizing typically, and being able to abstract it, and then being able to communicate it.
Absolutely. No, I 100% agreed, and that's a very good explanation that you just given. Excellent. So, David, my next question is a bit off piece. Can quality sorting good and bad types of cloud result in too much data processing, which is needed to make an informed decision?
The way I would approach it as a data scientist is I'd say, before we have any judgment around or categorization or classification of clouds, why don't we first just gather data? And when we're gathering data, the lower level the data we can gather, the better. So maybe we should gather data about precipitation. Maybe we should gather data about albedo effect. Maybe we should gather data about temperatures, which is a very hard question to measure. Right now, there's satellite data on radiance, and then there's balloon data on temperatures, and then there's ground surface data, and let's gather all that data. Step 1. Then we'll organize the data. We'll see what happens. And then maybe perhaps part of the data we gathered was some sort of visual definition of a cloud, multiple, high level, high humidity concentration in a certain area, right? And that becomes the definition. And then we can have some visual feedback on when that became. But what I would expect to find is that the data itself would help us. So for example, if we're measuring the amount of radiance being reflected back up, which is something they measure with satellites today. So you have the sun generating energy. It's never simple. But every time I've looked into this, there's a model on top of a model to try and actually measure this. So I don't think there's an exact measurement, but to my knowledge, but it's not my field. But if we were to measure the amount of radiance being reflected back up, or being absorbed, reflected, etc., then naturally the data would come into two groups. There'd be 0, everything's going through the higher atmospheres, and then there'd be another group which would be higher. And if we were to try and determine the spatial distribution of those groups, maybe we'd find, there's like a locus of high reflective material here. We'll call that a cloud. But till we got to defining the word cloud is 5 or 6 steps. First, gather the data, let the data organize itself, and then we can try to decide what appears there.
Absolutely. Understood. Understood. And that's once again, your analogy is very, very understanding in the sense of, there is a finite until you can class something as a cloud, you have to carry out the various processes and steps in order to identify, what type of cloud it is and where it falls between what is already known that is either low or high and what's in between potentially.
Right. And we were discussing how the industry today falls into this trap all the time because your CEO, your business development person comes in and says, the customer wants this, so we're going to measure this. And instead of saying, why don't we just monitor the customer's behavior, we'll figure out what the customer really wants, and then we'll just figure out that way. So gathering the data, unbiased gathering of data is a very big challenge. And it's something that I think, one of the key words we use here, the phrases we use here is trying to shift our world from heuristics to statistics. We think naturally as heuristics. We think about, oh, this makes sense. The customer said he wanted this. He probably does want that. But if we watch his behavior, we can determine statistically what he actually is looking for.
Yeah. And that is the case throughout the world, as we see. So very true. Brilliant. Okay. Are there any books that you'd recommend to our audience to read?
Yeah, it's funny. There's so many different books that I enjoy. I happen to be reading something this week. We talked a little bit earlier, and this wasn't on my book list, but I came across it again. I was reading Sages and Dreamers by Elie Wiesel, which I really enjoy reading. I don't know if it's because I'm a Talmudist and that's why I enjoy it, but his thinking is always both very humane. I don't know if that's the right term, even.
Yeah, it is. Absolutely.
And very insightful. And so he analyzes, or he discusses stories of famous people, famous rabbinic scholars, and he looks at it in a completely different perspective than I would have at first. And it's always insightful. And so that's what I'm reading this week. In particular, I was reading the chapter on the 4 that tried to enter the forbidden knowledge. 4 people entered the forbidden knowledge, and 1 died, 1 went crazy, 1 came out okay, and 1 changed his path completely. And when describing that, he comes, I'm going to spoil it. It's a spoiler, I apologize. But for example, he'll say in that one, forbidden knowledge is trying to change the past. And we all experience this. We all try and change the past. And it's a clear way to go crazy. You can't change the past. You have to be at peace with what happened. And that's an insight. Anyway, that's Sages and Dreamers. That's a great book. All books are great. Just read a lot. Yeah. I shouldn't say all books are great, but many books are great.
Absolutely. I remember when we spoke, you talked about Tell Me a Story.
Yes. Yeah, that was on my mind. So I think the fun thing about that book is, Roger Schenck, the author, so is early in days of AI, he came up with this idea of scripts, that the way intelligence is stored is through stories. And he spent a lot of time with his daughter, I think, that was growing up at the time, and he recorded her conversations. And he said, "Oh, look, they're templates of stories, they're typing." And in the end, none of it really worked. And it was kind of, later on, it was definitely pushed aside for more statistical approaches and lower level analysis. But what's happened now and more recently is because we have more data, we're seeing narratives and stories reemerge as an element in AI. Mm-hmm. And that's very exciting for me to see how we've kind of come full circle, and some of his ideas are more relevant now.
Brilliant. I think, I've sort of looked into it, and it's early days for me, but absolutely it's very, very interesting in the sense of, how, once again, it's about language and how we sort of interpret language using technology and try to have better informed information to make decisions. Yes. Language is key. And yes. Understood.
Yeah, I spent some time studying semiotics and a little bit of linguistics, but mainly semiotics. And to me, it definitely is in conversation with information theory, which is in conversation with the basics. So I mentioned it on a different conversation that Umberto Eco has a book, a series of essays called On Information, where he does that connectivity between semiotics and information theory. And I think the the religious aspect of humanity being unique through its ability to communicate in language and speech, to me, is also significant. When I put all those pieces together, the value of language is constantly, never ceases to amaze me. And that's why I was saying read any book is good, because it develops your language skills. So reading is valuable.
Absolutely, sir. 100% agreed. I can agree. Absolutely. Very, very true. Brilliant. Okay. So my next question is, David, in your spare time, what do you do outside of work?
Right. So I have a family, thank God, and I'm blessed with a large family, relatively speaking, that is an investment in time, we'll call it. It's a big investment in time, and that's really wonderful. And thank God my children have started to grow up and leave the house, and I'm starting to reap rewards from that and have actually less time with them, and they have more time with their spouses. So then I have more time to do other things. I continue to enjoy learning and reading. So I'm a religious Jew, so I study Talmud, and I've been involved in different techniques of studying Talmud. So the idea of how to learn is constantly fascinating to me. And most recently, I ran a little group where we kind of create together new methods of learning. So that was a lot of fun. And I enjoy cycling. And cycling is a sport that takes up a considerable amount of time. And I definitely enjoy the outdoors. So being outside.
Absolutely, absolutely. It sounds as though that you've got, you pack exactly the same enthusiasm with your work as you do outside of work with your family and everything else that you've got engaged. So that's really great to hear.
I think that's why I found the question a bit funny, because you said outside of work, what do I do? And it's I don't know if this is absolutely true, but I'd like to believe it to be true, that I have a very holistic experience. And for example, at the Shabbat table with my kids around the table, I'll discuss ideas that came up during work, and we'll see how that integrates with ideas that we have here and in our life and in the Talmud and whatever it may be. And living that holistic life works for me, because it's too much to try and break it up. If I don't connect all the pieces together, I'm not able to manage the noise.
Like you said, absolutely, you are blessed because you're able to do that, and that's really great to hear, because that's a difficult challenge that I think a lot of us are struggling to do. How do you sort of incorporate your work with your home life and, have that sort of interchangeable dialogues? So that's really great to hear, and impressive as well, because that's not easy. So it's really great that you've been able to incorporate that into your holistic environment, as you just mentioned. Brilliant. So that brings us to the end of our CTO News Thursday vlog recording with yourself, David. And I'd like to really thank you for your time and the insights that you shared, not only about Blue Dot, but also the TaxTech sector, and also your use of technology, specifically around AI, ML, and data, which is the core to everything for everything that's happening within that environment. So thank you. Over to you.
My pleasure. Thank you.